from the Pisces into Aries, that will move by 1 day every 70 years. So now let's try to understand why Robert Knox talked about a new year on March 27th and why it is now on April 13th. So when Robert Knox talked about it in 1681, the British world was still in the Julian calendar. So we are talking about March 27th in the Julian calendar. So you have to add 10 days to that to make it April 8th to be in the Gregorian calendar. Now from there was about 330 years since 1681 to now 2010. So there is another 5 days, 4 to 5 days added on to that, so which makes from April 8th to April 13th. So that's how the new year now is April 13th. Unfortunately, this definition would mean that every 70 years we would have an extra day. So another 70 years into 2080, we will be celebrating New Year on April 15th.
Right. So it's quite a story, isn't it?
And then another 70 years, we would be 16th. And you know, this will start going further and further on. So either we'd have to change, and the same thing that happened in the Western world, where they didn't want to have this spring festival in summer, that they defined the Gregorian calendar to fix it at March 21st. So now we'll also have to decide, do we really want to let our Sinhala New Year drift into May?
Right.
Because it will be not what we are used to, but it is actually what will happen every 70 years. We will go. And if you remember, I mean, 70 years back is not very far. People in the 1940s or in the 50s, the Sinhala New Year was then generally between the 12th of April and the 13th of April. Not now, it is mostly between the 13th and the 14th. Now, why it switches from 13th to 14th is the leap year. So every year is 365 and a quarter. So that quarter gets accumulated into one full day. So it will go from the 13th on to the 14th, and then we'll have a leap day on the February 29th, and then it will go back to the 13th, and then gradually it will drift into the 14th and the 15th, and then it will drift again. So
right. So it's actually quite a story. I never thought that that particular question will require such a comprehensive answer, but it explains as to how these calendars are set and how there's a transition in the calendars and the leap year and so many concepts. And also moving on, you also said that at NASA you were also dealing with the Hubble Telescope, and you also did many discoveries. Do you want to speak about some discoveries that you've already done?
Yes, I would like to. One of the most exciting things was I went in 1992 to discover, research with the Hubble Space Telescope, and what I really did most of my work was we were taking photographs of random regions of the sky, and they were taking it actually when the one of the other instruments were doing research on a region. We took the parallel data and we got lots of data, and I wrote computer software to automatically analyze this data and find out new things. And very excitingly, in 1995 we were expecting to discover gravitational lenses. Now gravitational lenses goes back to a prediction by Albert Einstein in 1917, where he said that very massive objects like the sun or galaxies would bend light. Now normally we think of light only going in straight lines, but the general theory of relativity more or less said that light is bent by massive objects. So the first thing that they did, it was one of the things that was used to understand Einstein's general theory and to prove that it was correct, was to try during a solar eclipse of 1919, Arthur Eddington tried to see whether there was a slight difference in the direction of stars that you could see close to the limb of the sun. And that thing was successful, and people accepted Einstein's theory of things. And a consequence of that Einstein's theory is that if you have a massive object like a lens would bend light, that a massive object like a distant galaxy also would bend light. And by that you could create a position where you get mirages, like you would look at from a bottom of a wine glass, you would see multiple images that the galaxy would create multiple events. Now we have that was predicted back in 1938 by an astronomer named Zwicky, and he predicted in 38. It was not observed till 1979. The first gravitational lens was discovered in 79, and I was lucky to be in the group that discovered the first gravitational lens with the Hubble Space Telescope.
Right, that's a very interesting point, Doctor. Let's take a small break, and we will be back with you soon. Stay with us.
Number 1 is Colour of Love.
Britsbury Chocolates, Sri Lanka's #1.
Welcome back. You're watching Roundtable, and we are speaking to Dr. Kavan Ratnatunga, and he was elaborating on his experience at NASA, especially with the Hubble Telescope and what he discovered. Continuing, Doctor.
So I was talking about the gravitational lens, which we discovered in 1995, and I will show you an image here, and I hope you can zoom into this. The image here, and that is not showing too well, but what it basically has is that this very distant quasar has a light which is coming out, and it is being distorted by the lens, the galaxy, which is a massive object, is causing, and it creates 4 images on either side of this galaxy. And that sort of quad lens was created a great understanding that Einstein's theory of general relativity, which he put in 1970, was really working, because we can only understand something like that with that sort of theory. We cannot understand it with Newtonian physics. So this is one of the examples where we can of astronomy, which has, and it's quite exciting to be actually part of that discovery in 1995.
Exactly, because when it is a discovery, you are actually doing groundbreaking stuff, and challenging Newtonian physics itself. I think it's a hell of a thing, because that is what we are conditioned by. So, and also, Doctor, on the same note, can you elaborate as to what is exactly the study of astronomy? What is it?
Okay.
Now, first you said that it was also the study of the universe. So,
astronomy really is, I mean, if you take the historically, it sort of grew up from people's interest in astrology, which is completely now a completely different part of it. I mean, as most astronomers will not talk of anything to do with astrology, but if you take in the 1600s and the 1500s, most of the astronomers got their money by being court astrologers to the kings, because that was, they had to make a living. But since Galileo in 1610, sort of the astronomy, the field of astronomy has diverged heavily from astrology, and now we have absolutely nothing to do with astrology, but astrology is based on an astronomical framework, and that is why I think you can prove that it is false.
Okay, that's sort of a very challenging statement. I think that should be another discussion about comparison of astrology and astronomy, and challenging the validity of astrology.
Right.
So, coming back to the as to what exactly astronomy is.
So, astronomy is where we are basically studying both our solar system, where we know that the planets in our solar system and the sun, how it evolves, how it formed, as well as other stars in the sky, which are all stars. The stars we see in the sky are actually suns, as bright as the sun. They are just very far away. Now, the sun is about 8 minutes, light minutes. Light takes about 8 minutes to come from the sun to the earth. So, that's 93 million miles, and it takes 8 minutes at the speed of light. Now, the nearest star, which is also a sun, is 4.5 light years away. So, in comparative to the sun, it's extremely far away. Our galaxy is 100,000 light years, and the galaxies we are talking about here are a couple of billion light years away from us. So the universe is 13 billion light years across, because that's what we consider the age of the universe to be. And so it's a massive, extremely large area that astronomers try to